So welcome back, everyone. So this afternoon, we continue our deep dive into the industrial case studies and technical excellence.
Without further ado, we are privileged to welcome our next plenary speaker, Dr. Leslie Joy L. Diaz, a professor at the Department of Mining, Metallurgical, and Materials Engineering, and currently serves as the Associate Dean for Instruction for the College of Engineering here at UP Diliman.
A distinguished alumna of the Tokyo Institute of Technology, where she earned her Doctor of Engineering in Material Science and Engineering, Dr. Diaz is a leading expert in sustainable materials research, specializing in green composites and environmental remediation.
She is also instrumental in upholding professional standards nationwide as the chair of the Materials Engineering Certification Board, a recipient of the Outstanding Engineering Professor Award, and recognized as an inspiring woman engineer. Please join us on stage, Dr. Leslie Joy Diaz.
Thank you, Nathan and Denise. So good afternoon, everyone. So thank you for the organizers for giving me this stage to be sharing with you my experience as a faculty member in the university in helping mold future engineers of our country, and of course advocating the specialization in failure analysis and investigation. So my title I have slightly revised. Okay. So from classroom to plant floor, preparing the next generation of investigators of material failures. Okay. The flow of my slides will more or less now explain why I change it from failure analysis to investigation. Ayo. Okay. All right, okay. So let me start by showing you some examples of failure that we experience, of failure of engineered systems that we recently have heard from the news, and of course, local in the country, okay? So we can see here yung Cabangan Santa Maria Bridge na nagfall. That was inaugurated in February 1, and after a few weeks, dun siya ngayon nag-collapse after a heavy truck, okay, loaded with construction materials passed through the bridge. Okay, so the incident involved a 1.2 billion bridge cost of the bridge, which collapsed after it was just inaugurated a few days earlier. Okay, of course, the impact of that failure involved fatalities, injuries, and of course, major economic losses. Okay? Another example would be just the same example that was shown earlier by Sir Mark, the building that collapsed. So earlier, the collapse happened a few days after it was inaugurated. This one collapsed while it is being constructed. Okay? So incident, a 4-story commercial building under construction in Angeles City collapsed, trapping and injuring workers. The impact of that, of course, several fatalities. Okay, about a few days ago, or yesterday, I think, there were already 24 bodies found from the excavation. And now there are, of course, other injured people, and of course, alongside property and economic losses. Moving on, this one dates back long time ago, 1981. Okay? So you can see how probably we have not been able to address these problems. This was 1981, and this was the construction of the Manila Film Center under the Cultural Center of the Philippines. Okay? There was upper floor scaffolding failed while workers were pouring quick-drying cement. Okay? The pitch laborers and debris several stories down, burying them under the tons of wet concrete and twisted, concrete and twisted, parang may kulang. Okay? So of course, the impact there is about similar. Okay? Fatalities, injuries, death, And of course, here you can see rescue efforts were delayed due to political pressures to continue construction of the upcoming Manila International Film Festival. Okay? So there is probably beyond technical this time, or negligence of technical aspects. Probably there's another thing that contributed to the failure, probably here highlighted as political pressure. Okay. So moving on, I will not go far outside UP. Okay? The University of the Philippines Integrated School building, okay, the one that you can see here, okay, was recently, okay, closed under structural concerns. Okay? This is the building that houses grades 4 to 12, no, of the UPIS that was effectively closed because of structural issues. The impact of that, possibly learning losses, economic losses due to halted operations, a need for reconstruction, and eroded public trust in engineering safety standards. So there's a lot of consequences to these failures. These are engineered failures. These are supposed to be showcases of our expertise as engineers. And yet, okay, they continue to happen. Okay, the oldest I have shown here is way back 1981. And it's happening also in the area, in the very place where we nurture supposed to be experts of engineering. Okay? So what's the problem? Okay? Now, of course, you can see also in the previous slides that the impact of failure of engineered systems products, okay, all has impact in these various areas. Impact to financial losses, impact to environment, and impact to safety. All this should be reason enough for us now to look at this more closely, investigate, ask why, how we can stop all of this. Now, failure investigation is something that have been offered in the department for some years back, and we define failure investigation in our courses, in the way we teach the courses to our students, as follows. So failure investigation is a process of understanding the key attributes of a particular failure and then identifying the likely causes of those failure so that those causes now can be used to do root cause analysis. And from the root cause analysis, we can move forward to doing failure reporting, analysis, and corrective action system, or FRACAS. Essentially, FRACAS is a cyclic loop. Okay? You can see here a cyclic loop that will help us prevent recurrence of failure. FRACAS here, if you can see, has 7 steps. Okay? So first starts with failure occurrence, failure reporting, failure analysis, root cause identification, corrective action implementation. And when one corrective action do not become effective, then you can go back to reporting or going back to failure analysis, doing root cause analysis, and now addressing another root cause that might have been determined now to see if it has been effective. Okay? So verification of effectiveness and monitoring and tracking. All this cycle essentially gives us that system of preventing recurrence of failure, or better, it's a cycle for continuous quality improvement of our engineering products, systems, and services. Okay? So essentially, if we now apply this, if we have had applied this from 1981 probably, maybe the problems we are experiencing right now might not have existed at all. Okay? So that now makes us ask, why has this not been applied? Maybe the answer would be because many of our engineering disciplines are not yet integrating this into our curriculum or into our ways of teaching our students. So let me now proceed. So failure investigation using the FRACAS system now has different outputs and different objectives. For an end user perspective, at an end user perspective, failure investigation can be now used to assign responsibility. When I say used to assign responsibility, whatever we produce from failure analysis can now be brought to court. And then the court now says, okay, ikaw magbayad dahil naka-cause ka ng buhay ng tao. Okay? That's failure investigation from the end user perspective, yung nasaktan. No? Ngayon, magbe-benefit ng failure investigation natin. Okay, probably another purpose of failure investigation is to prevent recurrence, as I've said earlier, no, by developing mandatory and regulatory compliance limits. So now saying, okay, hanggang dito lang tayo pwede mag-construct, hanggang dito lang pwede ang building height, ganito dapat ang column width or column diameter para mag-allow ng several heights of a floor. That now will help us establish mandatory limits, regulatory requirements, so that the end user will be protected and will be safe while using our engineered products and systems. Now these objectives, I always tell my students, na this actually, if we now use these as our objectives in the failure investigation that we do, this is actually public service. We directly serve the people. We do not serve industry. We directly serve the people who have been affected, who are victims of probably failures. Okay? Now, looking at the engineering perspective of manufacturing, probably of industry, failure investigation is done to evaluate reliability and know cause and mode of failure for development of better design of a product or a material. It also helps that company establish maintenance schemes or protocols that will now let it produce the maintenance procedure that it will now distribute to buyers of its products. Further, from the academic perspective, this failure investigation allow us now to help us broaden understanding of engineering systems and procedures and phenomena and mechanisms of failure that will help us now develop probably new ways of doing things through research, through innovation that we do with our students at different levels of the academic layers. Okay? So all this, okay, whether it is for the public or for the engineering industry, there's a lot of reason why failure investigation needs to be done. Moving on, in failure investigation, there will be a lot of success when root cause is identified. Okay? If you remember the fracas loop earlier, there's an important key there, or important element of identifying the root cause. And the root cause now brings us the corrective action, and the corrective action, of course, prevents recurrence of failure. Now, root cause here means it is the underlying cause. It should be reasonably identified. Ibig sabihin, kayang makita at pinpoint. And then therefore, that pinpointed event or activity or step can be controlled and can be fixed. And it can now help in the prevention of the recurrence of the failure. Kung hindi po ito kayang makontrol, hindi pa po yun root cause. We need to dig further. I always also tell my students, kung hanggang materials lang tayo, napakita natin ang mechanism of failure, but it doesn't tell our end user, how do I address that and prevent recurrence? How do I address my procedure? Where do I correct steps? How do I control my system? Kung hindi nila madadala sa ganung level, hindi pa po yun failure investigation. Hindi po naging natapos yung failure investigation doon. Okay? Probably napakita namin yung mechanism, pero hindi tapos ang failure investigation. Okay? So with that now said, okay, root causes, there are different sources of root causes. This is one example of my students just this semester. And now the failure here is a shear blade failure from a manufacturing company. And you will see that there are different reasons, from material, okay, to process, to equipment, to human factors. And sometimes there's also from environment. No? There are different causes, and addressing all of these at the same time, or even randomly picking from this, would not even mean any address of a solution, a provision of a solution to the problem that was encountered. Okay? Thus, there is importance of doing a process, integrating fracas to now one by one prioritize, filter out which corrective actions are not effective in addressing the problem. So now you see another representation of that fishbone diagram that you saw in the previous slide is this diagram over here. You can see here a Venn diagram that illustrates the sources of root causes from physical to human, and even here to latent. What do we mean by latent? Latent means cultural, organizational, rules leading to human causes. Okay? So kung napapansin natin, physical is just probably the first step. Diba? Tapos, kung hindi natin makita sa physical, then probably human error ito. At kung malamang nagka-human error yun, because probably there's a bigger problem in the organization. Yeah? Na parang kahit palitan mo yung human na yun, pwede pa rin mag-recur yung problem because the problem is really organizational, systemic. Diba? So parang we're saying here that, there are different sources of these causes, and therefore the process of eliminating, the process of investigating this from the physical to human to latent now is what we would like to teach our engineers. Okay? In the department, we offer these different courses, no, that now we allow our students to go through the different process that you saw there earlier, from failure reporting now to involving some corrective actions. Okay? So from this period we have in metallurgical engineering, okay, I started teaching, by the way, this is about my 10 years of experience in teaching this course. And I started teaching in metallurgical engineering, failure and degradation of metals in this period. So it's about 10 years now that I've been handling this course. And in materials engineering, okay, I started also teaching in this course in this period. And the title of that course is Forensic and Reliability Engineering of Materials. Okay? Now, in addition to this, there's another course in materials engineering that's called MAT E171 and looks at degradation of materials. Okay? So if you look at the title of these courses, you can now imagine that starting from the metals, the materials, the polymers, the ceramic materials that we encounter in different engineered systems, our students now look at it in a lens of not synthesizing, not fabricating, not creating a product, but really now looking at these materials from the perspective, how do they degrade when they are in operation, when they are being used? How do they respond to stresses? How do they respond to environment where they are exposed? Okay? And when these now are understood, okay, when failure occurs, okay, when unpredicted failure occurs, then the students now can go back to, okay, what are the signs? What do we see in the failure that our materials underwent? From these signs now, we will determine whether it is about mechanical, whether it is about chemical, whether it is about thermal, and therefore allow us now to pinpoint where in our sources of root causes will we now be digging further in so that we get to the root cause of the problem. And probably now end up with a more effective corrective action. Okay? So now, this is what we offer in Triple ME, but I have not heard of any of these similar courses offered in other engineering fields. Now, Triple ME has been motivated in offering this course because materials engineering started because of the semiconductor industry. So if you recall from the presentation of Sir Mark this morning, the semiconductor industry, one of its core discipline really is doing failure investigation, failure analysis. Okay? So because of that, many of our graduates are actually doing failure analysis and failure investigation in this industry. Okay? Now, however, semiconductor industry is just one industry in the Philippines. There's so many more industries. In fact, what I've shown earlier in the earlier slides are all in the construction industry. Okay? That I'm not so sure of if there is a system that exists now to address failure investigation, failure in this sector. So moving on, going back to the case that I have shown you earlier, I just want to showcase some examples that my students did in this course. So this is UPIS, a building that was recently closed. And now there was a failure investigation done by my students in way back 2022-2023. And this was the root cause diagram that they now were able to develop. From this root cause diagram, medyo maliit ang font, no? Pero essentially, meron silang iba't ibang sources of failure that now, root causes of failure that now they could not filter further because, of course, the time was limited and there was limitation in terms of Okay? In terms of lack of information needed to further investigate our failure, that failure. Okay? Kaya, pagkadadulo ng semestre, ang inabot daw ang estudyante, there could be, okay, if you notice there are likely cause, there could be inadequate amount of reinforcement, or there could be, the design load could be below the actual load experience. Now, of course, this could have been verified further if we had contact to the contractor of this building. However, of course, no, because being students, we had limited access to that contractor. And the system in the university somehow limited us from accessing or contacting those, the contractor of this building. So, from our perspective, when we did this investigation, it sort of, we had to classify it as a cold case. Moving forward, another investigation that was done by our student is about this sprue bushing of a casting company in somewhere in Marikina, and they now investigated the failure of this bushing part of a casting equipment. Okay, so this was the incident, and they had findings and recommendations here. So dahil limited po ang aming exercise at saka wala pa kaming MOA, wala pa kaming Memorandum of Understanding or Agreement with them, parang nalimit lang kami dun sa mga kakilala namin. So medyo limited dahil one sem lang, ito lang yung kanilang evidence, and then they had some literature review that they did for the company using the resources that we have in our library. Okay? So moving forward, okay, as I have said, okay, earlier, going back to this diagram again as our root causes, our experience from the failure analysis exercises of the students when they enrolled our courses sort of became limited because the time was limited. And of course, there is a bigger need for collaboration with our partner companies. And the collaboration, of course, will require MOA, will require continued collaboration or sustained and documented collaboration. So we are not there yet at this time, but it is clear to us that as materials engineer or metallurgical engineer, our focus is on this part, the physical aspect. Okay? So in any failure that happened, we always have starting material as our starting material, the material evidence that we will find from the failure incident site. Okay? So this material evidence undergo material analysis, material failure analysis. However, there were several instances when my students encountered that there was no problem with the material. Hindi po siya hindi po siya pangit na quality. Okay? Maganda. It is consistent with what is written in the standard. Therefore, material is not the problem. Okay? So what next? Where do we go next? If you recall the presentation of Sir Mark earlier, putting human. Okay? Human factor. A very technical problem with a non-technical solution. Diba? Imagine niyo yung naging itsura lang kanina. May operator na naglapag ng isang component sa isang maduming surface. That alone already resulted to a very difficult problem that the company had to address. Okay, otherwise, di ba, pwedeng masira sila sa kanilang mga kliyente. So the human factor there, the human factor there is probably the next, kung hindi simultaneous possible source of root cause, no? Pwedeng kung wala tayong makita dito, the human would be next, no? The human investigation would be next. Now, human, ang mga estudyante po namin hindi po sanay na makipag-engage sa mga hindi sila trained to engage with interviews, no, with people na syempre kapag nakipag-usap ka sa mga ganitong instances, dapat meron kang caution, di ba? May mga pagtatanong ng mga neutral questions na hindi kami sanay sa ganun. Medyo very directed and very technical yung mga questions ng ating mga estudyante. That's how they have been trained. Now, it occurs to us now na mukhang kailangan din namin magkaroon ng perspective on the social science aspect of now dealing with people. Okay? Now, kung hindi naman human, okay, syempre ito madali itong gawin mo. Kahit pumalya-palya ang mga estudyante sa pag-i-interview, pwede pa rin magawa. Pero kapag ito na yung naging problema, hindi talaga human, but really the organization is having the problem. No? As I've said earlier, kahit palitan mo yung tao, kung ang organization ang problem, mag-occur yung yung failure. Okay? Parang dito tayo pwedeng tumingin, di ba? So as I've said, 1981 pa yung construction issues natin in the past, and until now, we are still experiencing that. Baka nandito na po yung problema natin. But we have not been able to investigate on that and build up on that so that we can prove that this is where we need to address issues on. Thus, okay, with that said, I would say failure investigation could actually lead to innovations. Innovation in practices, innovation in operation, no? Innovation in products, in systems, no? However, for us to realize that, as materials engineer, as metallurgical engineer, we only will be able to provide confidently physical evidence. There is a need to collaborate with other engineers in the other fields of discipline. Probably, as I've said earlier, there might be a need to collaborate with social scientists. Ay, nandito pala sa baba yun. Other scientists and technologists. Kanina nakipagkwentuhan po ako sa PTRI. At ang kwento nila, yung isang sewer, yung nananahi. Okay? Siya mismo, dahil expert siya sa pananahi, siya mismo yung nakapagtanong at nakapagbigay ng input para ma-identify yung root cause ng problem. They are not engineers, but they are experts in their practice of profession. Okay? Thus, there might be a need for us to collaborate with them. And as I've said earlier, for interviews with people to now find out the important information or data from interviews, we probably would need to work with social scientists and probably organizations, among others. Thus, my call to action would be, let us train more forensic engineers, not just materials engineers and metallurgical engineers. Integrate this in the engineering curriculum, not just of curricula in our department, but also in other disciplines in engineering, and give more stress in engineering ethics. There's a lot of issues that we are encountering today that seems to be, diba, nandun siya sa ethical issue, pumapasok. Thus, I'd like to end my presentation with this, no? From classrooms to plant floors, our role as engineers is not just to fix broken systems, but to safeguard lives, industries, and futures. Further, as engineers, let us commit to being steadfast guardians of safety and integrity, especially in moments when industry and politics intersect and when personal interest threaten to overshadow the common good. Good afternoon, and thank you very much for your attention.
Thank you, Doc Les, for that very informative talk. So we firmly agree how failure is truly detrimental in several aspects, and how failure investigation is necessary in engineering systems, and how significant incorporating failure analysis courses in our curriculum. So thank you. We now have a few moments for a quick Q&A session with Doc Les. So if you have any questions for our speaker, you may raise your hand or you may proceed to the microphone at the center of the auditorium. Siguro ako po muna. May tanong po ako. So you have mentioned, Doc, na failure analysis is a parang multidisciplinary field that doesn't only require scientists but also, engineers but also social scientists. So since we are dito po, our focus is more on the materials, the metallurgical field in failure analysis. So how can we integrate po with the other fields such as in social sciences to improve our methodologies and our analysis po for these kinds of activities?
Alright. Social scientist yung tanong mo, no? Pero yung kanina sa engineering itself, no? Parang iniisip ko, nandito na yung failure analysis and reliability engineering sa Triple M for some years, ano. Pero parang hindi siya nag-propagate or hindi nahahawa yung ibang engineering disciplines. So, isa yan sa iniisip ko actually, no, paano kaya natin mapopromote ito sa ibang engineering disciplines so that everybody buys into the idea and of course, no, integrates it into the curriculum. The other thing, of course, is yung social scientists, no? Ibang kolehiyo, ibang mindset, ibang konteksto. Right now, I have no direct answer to that. Because sabi ko nga, even in engineering, nahihirapan po tayo, no? Pero sa tingin ko, baka itong mga ganitong activities natin, no? If we sustain this, if we keep on, ano ba tawag doon? Doing activities that will make this word a buzzword, no? Parang mas maririnig ng tao, mas mapag-uusapan siya ng iba't ibang kolehiyo probably, ibang industry probably, no? Probably industry could also help us inquire from the different engineering disciplines. Kunyari kung gumagawa kayo ng power, may power dito, yung sa power, di ba? Kung sakaling may mga failure investigation, I know our students have been talking to mechanical engineers. Probably you can help us identify saan ba sa mechanical engineering nga ito pwedeng i-integrate. Kasi kami, syempre, we can only know our curriculum. But because we have mechanical engineers dealing with the same problem, maybe you can give us idea, paano ba namin kausapin, paano ba tayo mag-integrate ng ganitong sistema sa mechanical engineering. Now, we have also from, isa sa mga, sabi ko nga kanina, kausap ko ang PTRI po, no? Yung research institute natin sa textile, sa fabric, no? So there's a lot of processes going on there, from fiber extraction to upgrading them, to fabricate, to making them into fabric, designing them into textile, di ba? Parang maraming processes na pwedeng ma-involve. There could be chemical engineering there could be manufacturing there, no? So parang maraming pwedeng posibleng maka-encounter. So we would love to continue doing this now that we have industry working with us, now we have research institutions working with us. Sana masustain po natin ito. This is our first. If you heard earlier, our chair saying that, hopefully sana masustain po natin para nga magiging mas marinig siya ng tao, magiging buzzword nga as I've said, no? At magiging fashion, magiging magiging trend, and probably many more will be encouraged to pursue and integrate this in the curriculum. So yun siguro yung sagot ko sa'yo, Sir Nathan.
So, meron pa po bang questions for Doc Les? Yeah, Sir Stan.
Hello, good afternoon, Doc Les. So, quick question lang, Doc. How important do you think are case studies, especially those that have industry partners, in teaching failure analysis class as opposed to using like textbooks examples?
Thank you for asking that, Sir Stan. No? I personally, mas kakapit po, para sa akin, no, mas kakapit yung learning ng mga estudyante kung sila ay direksyong nag-engage sa industry. Sana magkatuwang ang industry tsaka ang academe in molding the engineers that you want to eventually employ or you want to eventually partner because sila ay sariling mga company owners na rin. Ano? Nahihirapan, ako personally, no, nahihirapan lang akong i-sustain. Lagi kong sinisikap na merong palaging industry partner yung mga estudyante namin. Kaso medyo marami pa lang kaming hindrances within the university in terms of solidifying that collaboration, no? Kung narinig niyo naman siguro, marami kaming issues in terms of MOA signing, no, yung mga ganung bagay. Ang mga estudyante po namin 6 months lang po mag-aaral, di ba? 6 months. Yung MOA signing po namin, minsan lagpas po sa 6 months. Narinig niyo si Sir De La Peña kanina, sabi niya 9 months, di ba? So marami pa kaming hindrances, no? So right now, medyo personal ang engagement namin, no? Parang may kakilala kami o kaya may estudyante kaming nag-graduate na tumutulong sa amin na sana magiging mas rich yung encounter ng mga estudyante sa kursong ito. No? Nagiging mas meaningful sa mga estudyante, nagiging mas professional ang feeling nila, hindi yung nakaharap lang sa classroom, naghaharap lang sa blackboard, nakikipagkwentuhan lang sa amin ng kanilang teachers. Mas naramdam nilang professional sila at may kayang gawin for the society, for the industry, kung kasama po namin kayo sa engagement na ito, sa learning process na ito. So sana po huwag kayong magsawa. Tuloy-tuloy sana yung inyong pakikipag-engage sa amin. Kahit wala po tayong mga MOA, pero sana nga magkaroon na tayo ng mga MOA. No? So thank you for that question, Sir San. I hope na-address ko po yung tanong ninyo. So yan po.
Ayan. So, may questions pa po ba sa ating speaker? Yes?
Okay, so I have a question. Since you said po na yung failure analysis, GAP, nakikipag-usap po yung mga students sa iba't ibang industry, meron po ba silang na-encounter na hindrance na parang, yung iba po kasi hesitant silang magbigay ng sample kasi it speaks bad about their, Kasi for example, sa PTRI, like we are really willing, kasi we are willing to collaborate, pero meron po ba kayong na-experience na isang industry na hindi sila willing ibigay yung sample sila for that? And how do you address it? Or meron po bang current policies talking, parang addressing that? Kasi in some sense, parang kailangan din ng transparency then sa example sa industry, parang meron po bang current policies talking about transparency sa standards na ginagamit ng isang company? Ganun po.
Okay. Thank you for the question. No? From my experience, parang hindi naman sila nag-hesitate in terms of sharing to our students. No? Yung group mismo. Ang hesitation nagmumula actually doon sa, syempre dahil ito ay failure investigation, may mga data na kailangan i-share nila para maintindihan ng mga estudyante yung operation, yung history, may mga data na kailangan nilang i-share sa mga students. In those instances, sometimes we engage and undertake a non-disclosure agreement with them. So if you go down to the exhibit of our students downstairs, marami po actually doon naka-code na hindi naka-declare talaga. So for example, nakasabi doon na a manufacturing company manufacturing this kind of product encounter this problem. Hindi po i-declare exactly yung name ng company. So, because that's our commitment to the NDA that we have signed, no? So, parang mas nandun. Medyo mas may problema pa kami pagdating doon sa, syempre dahil sometimes yung company nagmamadali, gusto nila meron agad results. Yung mga estudyante po natin, marami pong pinagkakaabalahan. Meron silang research, meron silang design project, tapos isa pa tong FA study na to. So sabay-sabay nilang ginagawa sa isang semestre yun. So parang mas natatagalan si industry dun sa progress ng mga students. The other way naman is parang nahihiya din kami na nakikiistorbo kami sa operations ng industry kasi kailangan nilang mag-interview ng mga taong directly involved doon sa failure. Kailangan nilang minsan mag-ocular inspection. Kailangan nila ng essentially mang-iistorbo dun sa regular operation ng industry. And sometimes kasi syempre si industry, hindi naman yan agad-agad magbibigay ng very critical sa operation nila, di ba, na sana masolve agad para tuloy-tuloy ang operation. Normally, ang binibigay sa amin, yung mga pwede nilang how do I say that? Hindi ganun ka-urgent, kung baga, no? So thus, nakakahiya minsan mang-istorbo kasi hindi nga siya urgent, hindi siya needed. So therefore, parang kailangan namin maghintay. So mas nandun yung problema kaysa doon sa natatakot sila na ma-disclose yung kanilang parang probably weaknesses in the operation or weaknesses in the people that they employ, no? Parang wala naman kaming ganung problem. Yan.
Yeah. Yes, sir.
Hi, Doc Les. Question po, kanina nabanggit yung regarding dun sa weakness or gap dun sa human and latent aspect ng failure investigation. Ano po kaya yung pwedeng gawin natin sa engineering curriculum para change or addition or para ma-strengthen, para maging handa sila kapag umabot sila dun sa point na gagawin na nila tong failure analysis and investigation? Parang yun po.
In the several case studies that I've handled with the students, parang hindi kami nakakarating actually sa latent causes, Sir Brian, no? Kadalasan nandun kami lang tumitigil kasi nga very limited ang time, nandun kami sa physical causes, no? So parang na-identify nila kung ano yung failure ng material, ano yung mechanism kung paano siya nag-fail. And now, minsan nakaka-extend towards saan sa operation nanggaling yung cause ng failure na yun, ano? But like digging further, bakit nag-fail yung operation, ang step ng operation na yun? Was it because of a person problem or was it because there was problem in the organization na pinag-overtime yung tao na yun for 2 days na hindi na train, no? Parang hindi kami nakakarating sa level na yun. And I think sa BS degree curriculum, mahirap siyang ipasok pa further. Baka magandang pwede siyang maging either a micro-credential that we can offer in the department in collaboration probably with IE dahil mas expert sila sa organization or industrial engineering for those not familiar, no? Mas marami silang organizational perspective. Or probably a part of the MEng program that we offer that we will develop in the department. So parang higher level siguro siya, Sir Bri, kasi medyo mahirap na isiksik pa sa undergraduate level natin. Yun po. Okay.
So, I wait. So, for our last question. Sige.
Hi, Doc Les. So for my question lang po, since syempre I'm one of the students currently taking yung Math E173, the first things we're taught about failure analysis na is syempre hindi dapat tayo biased, we should cover all our bases regarding to failure, and but admittedly this is also hard to do kasi syempre limited tayo sa time, equipment, bureaucracy within the university. So I was just wondering na given this, do you still think there's still room for improving our curriculum in the future on a systems-wide level, considering then how we talk with our industry partners? For example, maybe adopting the systems we have in place for our Math E190, our internship, and having established partners already who are willing to adopt students to do failure analysis, or do you think that we should prioritize instead focusing, instead of putting new systems into place, we should prioritize instead focusing on doing things earlier or addressing these problems of equipment and time more directly?
Pwede bang both? Of course, we can approach both, ano. Pero ideally, parang para sa akin, para tayo maging mas effective in addressing engineering failures in the country, dapat mas system level ang approach ng pag-address ng improvement natin sa the way we offer materials engineering failure investigation, no, and in metallurgical engineering failure investigation. So system there right now, no, hindi pa ganun kaklaro sa akin. Pero right now, our students are actually engaging, kunyari lang, consultants. You guys, no, have been engaging consultants from different departments in the college, no. So kunyari dun sa mga involved dun sa isang building failure, no, merong nag-engage sa ating civil engineering. So right now, several instances na po yan, no, and we just didn't have the chance to discuss with one of the faculty members who have been the favorite consultant of the various building-related failures na in-investigate ng mga estudyante. Pero parang sa tingin ko, pwedeng mag-usap ang, kunyari, civil engineering, tsaka tayo sa MMM, to now evaluate how can we work together, set up systems so that consultancy mechanism is not just parang short-term engagement, no? Kundi parang sana even madala to the level of the students, na even our students now engage their students to now look at together, no? Dahil hindi lang tayo na mga Math-E or METI ang nade-develop, pati din ng mga siguro civil engineering students nade-develop in terms of how they now should address failures that we encounter in the country. Equipment and other resources or facilities, I think, will follow if now the industry will see benefit of that. A good example really is what we are experiencing in the department, diba? Tumaya si SCPC. Si SCPC, tumaya siya dahil nakita niya ang benefit na ginawa ng department, ng mga estudyante natin. So, yun sa tingin ko, pwedeng magsimula muna internally with the discussions we'll make with the case studies that we've done with them, and then hopefully mas may magandang sistema na ma-improve or ma-set up. And then now industry and probably government can pitch in as soon as that is developed and proposed to them. I hope that addressed your question, Rennie. Thank you.
Opo, Doc, thank you.
So thank you, Doc Les, for your insightful responses, and the audience for their insightful questions as well. So to express our gratitude for your time and expertise, we would like to present this token of appreciation to Dr. Leslie Joy Diaz. So calling on Sir Stan to the stage.
Basahin ko na lang, Doc. This certificate of appreciation is presented to Dr. Leslie Joy Diaz for their invaluable contribution as a plenary speaker in Interface 2026, held on June 5, 2026 at DMME University of the Philippines, Diliman. Signed by me and Doc Mitch.
Before we proceed to our next segment, may we request everyone to magte-take tayo ng picture. So please stay on your seats. And yung magte-take po ng picture, dito na lang sa stage. Thank you. All right. So shifting our focus from industry perspectives, we now spotlight the emerging expertise within our own institution. Our next segment features technical case studies meticulously prepared by the department's very own undergraduate researchers.
Yeah, that's correct. So we shall now commence the oral presentations of our failure analysis case studies. So to maintain our schedule, each presenter is allotted 10 minutes, followed by a brief lightning Q&A session with our esteemed panel of evaluators.
So to introduce our panel of evaluators, can you please stand up as we call on your names? Mr. Mark Cabading. We have Sir Stan Ejera. And Mr. Mark Buado. To initiate our afternoon presentations, please welcome Renee Isabel D. Garin as she discusses their research, Premature Failure of the LPG Cylinder Marking Dies, a Forensic Failure Analysis.
Paano po i-ano? So, okay. All right. So, hello po. Good afternoon, everyone. It's not really noticeable right now, but I'm shaking a lot. So I hope you guys will take away something from this presentation as we have for the entire semester. So my name is Rini, and today I'll be presenting our investigation entitled The Premature Failure of Liquefied Petroleum Gas Cylinder Marking Dies, a Forensic Failure Analysis. How do I? Okay, sorry. So this is our product background. So LPG cylinders are required to be labeled according to the requirements of the customer, according to the Bureau of Philippine National Standards. So to do this, usually a high carbon steel with engraved letters is used to indent the important information on either the global checkmark seal quality, the data plate, or the property owner mark. So as we see here, in figure 2, the plates successfully marked with dies are then transferred onto the colors of the LPG tanks. So here was the problem encountered by our client. So ICD2 carbon steel was sourced from Germany and locally as well, and it was engraved via electrical discharge machining and then passed quality inspection at our client. So these dies are then installed into mechanical press machines where they're repeatedly used on the LPG tanks. So missing features were noticed, and this constituted a premature failure after only about 8,000 strokes instead of the expected 20,000 strokes. This was confirmed by presences of chipping, damaged letters, and these were tagged and later on failed and removed from use. So because of this, the objectives now of our team was as follows. We wanted to first determine whether the failures of these marking dies were predominantly attributable to material defects, manufacturing processes, or a combination of these. And we wanted to characterize as well the microstructural features of the failed dies and see what any and take away whatever corroboration we can and compare investigating machine and material. So because of that, these were the theoretical causes of degradation and failure that we proposed. The first is the EDM recast layer, improper heat treatment, fatigue failure, and impact overload. So here we can see those integrated in our causal chart, showcasing the life of the ICD2 as it's prepared by the supplier, heat treated, and as it's engraved and eventually used and in the mechanical press operations and where it eventually failed. Right. So our failure analysis methodology largely constitutes of visual inspection, hardness measurement, and later on metallographic analysis. So this is the sample code I will be referencing throughout the presentation. So for the two failed ICD2 samples, we have 1F and 3F compared against a control of an unfailed 3NF, and we also did a further comparison with SKD11. So initial macro factography results showed the following signs of fatigue wear in the samples. So here we have chipping, wear, and cracks. So chipping here was shown usually sa mga curved edges. We have the oblique impacts here showing a brittle failure mode, and wear was found in all samples, but more notably in higher in concentration for the failed samples here. So wear is inevitable, but if gathered in enough concentration, it also can lead to effects such as the letters not being embedded properly during use. So chipping was only found in like one instance here in the check mark for sample 1F. So this is likely due to the stress concentration at this sharp corner here. So for results of NDT, a significant hardness gradient, that is, there was a significantly different there was a phase that was significantly different when we took the hardness. So a significant hardness gradient was found for both sample 1F and 2F, while it was relatively consistent dito sa sample 3 and F. And the elemental composition as well was expected elemental composition for ICD2 was also found in all samples, though it should be noted that there was a higher concentration of zinc, magnesium, and carboid found in the good samples. So dito so here in the inset bar graph here, we can see that the samples 1 and 2, the red and blue graphs here, have notably lower counts of these alloying elements, and the SKD sample also had a much remarkably lower count of vanadium here.
So this was also similar to what we received from the client. And here as well, we have the identified phases for chromium steel. So chromium in ICD2 has a tendency to form carbides as it's quenched and tempered. So here we see those primary and secondary carbides here. And in the matrix, we have retained austenite and some formation of coarse martensite. So this is typical of, according to literature, this is typical of quenched and or low temperature tempering samples. So moving on to discussion, so a key point here in our analysis of the metallographic structure is the microstructural evolution of ICD2 steels as they're tempered. So over time, after quenching and as tempering temperature increases, we see here the decrease of retained austenite and an increase of fractions of tempered martensite and coarse carbides, indicated here by the precipitation of large angular carbide structures in the grain boundary network. So generally, as in literature, the hardness levels, the hardness of ICD2 steel tends to decrease as the tempering temperature increases, because as we recall, the reason why martensite is hard in the first place is because as it forms, carbon is trapped inside the martensitic structure, so which increases hardness. So tempering reheats that structure and increases the diffusion of increases the diffusion of carbon, thereby decreasing its hardness in exchange for finer and more ductile tempered martensite. So this was consistent with our findings. So here we have a comparison of the microstructures of sample 3 and F and the first failed sample here. Similar po ang hardness nila, medyo similar din yung microstructure. So, but if we compare different areas of the sample 1F, we can see that mas coherent ang carbide network in some areas, while in others, it doesn't seem like the carbides have precipitated in much of the grain boundaries yet. So, so comparing these two, at least we can say that there may have been other factors as to why nag-fail ang sample 1. What's more interesting, however, is the comparison of our control to sample 2. So here we have a hardness of 53, which is much, much lower than what we got in hardness of 59. And then here we can see the coarse carbide formation here. So mas coherent ang network niya along the grain boundaries, tapos mas maraming ding dark phases, so there's a larger presence of tempered martensite as well. And this was found to be generally consistent among different areas that we checked. And we can see here that since my difference in characteristic microstructures between the two failed samples, we concluded that possibly during the production process of the ICD2 sample, there may have been a difference in tempering and heat treatment, with sample 2F having been over tempered with the presence of more coarse carbides, and as well having lesser counts of zinc, magnesium, and copper, because alloying elements also affect how hardness is the final hardness of the sample. So, all right, I will be glossing over this. Right. So, however, because there are other possible factors that we unfortunately had limited time to check, but still wanted to consider. The first is the actual manual ramp impact force. So these samples failed under operation of a mechanical press instead of hydraulic press. So the mechanical press, so essentially what happens here is that the die is loaded up into the mechanical press and then released abruptly. So ito ang nominal pressure and speed that we obtained from interviews with the client. And further emulating it in software, we calculated the force, the theoretical force needed to break the die, which is about 28,000 kilonewtons. This was based on the hardness, on the lowest hardness value that we measured earlier, which was about 53 for sample 2F. So even then, we saw, parang hindi siya abot, hindi umabot yung theoretical force to break the die. So for now, theoretically, we can say at least na parang yung manual RAM impact, hindi siya yung predominant cause of failure. What might have further contributed more, however, is the effects of electrical discharge machining, because it should be noted a bit more context that the samples before were engraved by another supplier, and then when we went and asked for further clarification on whether or not they do any post-polishing processes, sabi naman nila hindi. So an EDM recast layer is essentially this white brittle layer that forms on top of the engraved markings that happens due to resolidification of the material as it's heated during engraving. So the presence of the recast layer tends to include micro-cracking, and without the post-electropolishing needed to remove these, it can lead further on to cracking and other sorts of wear later on. Right. So for our conclusion, for our findings, so the first is that since we observed a difference in we observed a difference in characteristic microstructures between the failed samples and the unfailed samples. It implies therefore a brittle microstructure and an expected inverse relationship between what's supposed to be finer grains contributing to stress. So coarse carbides the coarse carbide distribution was also greater. Was also found in the failed samples, and this led to non-uniform stress response in the bad samples as to what they should have been normally in the good samples. So ayan. So our root cause hypothesis here for requiring further validation, of course, is that premature failure was possibly influenced by one, excess heat treatment or uneven heat treatment between samples, coarse carbide distribution, and the trace element composition that we gathered. So for further recommendations, it is recommended to further validate the heat treatment parameters, to go through exactly what is being used, and of course, conduct quantitative follow-up studies and other further investigations. So yes, we would like to thank everyone who has helped us, and thank you very much for attending.
So thank you, Renee, for presentation. So your group mates may join you on the stage for the portion from our panel. Or from the audience in general.
If I recall it right, from your first fractography images, parang I remember you saying that there was fatigue signs. Tama po ba yung narinig ko?
Yes, Doc. Wait, let me
Okay.
just
So from the fatigue signs, we know that it is, of course, because it's fatigue, then it's low loading, and there is a stress concentrator, right? So did you find the stress concentrator?
The stress concentrators, for now, according to what we've seen, is dito actually yung mga coarse carbides po. So dito po sa, wait, let me just go there. Dito po, particularly, it can be better seen here for sample 2. So here we are, according to comparison with literature, yung mga over-tempering sa mga ICD2 samples usually leads sa mga formation of coarse carbides. So this is them. So they form angular shapes sa grain boundaries, and because of their structure, these usually serve as stress concentrators as well. Kaya nagde-decrease din yung hardness, which might have contributed to fatigue wear in the sample.
Essentially, it's generally over the whole specimen. Hindi siya specific, yung fatigue.
Yes, because when we check multiple areas, it seemed naman na parang consistent naman yung structure niya for this sample at least.
Okay, thank you.
One last question from the audience.
Clarification lang, no? Kasi in relation dun sa question ni Doc Les, parang may na-mention kayo na possibility ng microcracks because of the, ano nga yun?
The EDM.
Yes. Hindi ba mas likely yon na stress concentrator than the carbides? If merong specific regions lang na nakikita ninyo yung marks ng failure. And clarification lang if these images are from your test or are these...
Apologies po, no. This is from related literature. So yung microcracking, tama naman po na it's possible na they could have been stress concentrators as well, which contributed to failure. Pero for our current limitations, the only way we can actually check if my recast layer is through SEM. And because we were not able to do that, it's a possibility right now that we further recommend na dapat need pang i-confirm and validate. Apa.
So, just a basic question lang. Were you able to piece together and link yung problema, yung cause, at saka yung recommended solution nyo to solve the problem based on this study?
Alright, so the problem here po kasi was yung premature failure. So according sa client kasi, considered failed po siya if, well, first and foremost, if hindi embedded yung pattern mismo. So actually, more than chipping, ang other than chipping po, actually, yung parang mas matindi na failure is yung wear, because we've been told na if hindi siya nag-embed, they just increase the stroke count, and then they just increase the stroke count of the machine, and that will lead to future problems later on. So, in terms of why this wear could have possibly happened, we can at least say that disregarding other possible factors, there is at least a tangible effect from possible improper heat treatment, because I'm looking at it. Because
Relax ka lang.
Ayun. We can at least say that there's at least a significant contribution dahil sa heat treatment. Kasi if nag-iiba yung heat treatment between different samples, that means hindi controlled ang hardness nila, and then because hindi controlled ang hardness and toughness nila, and hindi din controlled yung behavior nila under the operation. So ayun po.
So follow-up question, can you go back to the final recommendation?
Oh yes.
Right. So you said you have a client on this one, right? May client kayo, right, on this? And on your recommendation, were they able, so ang question ko lang is basically, were they able to, first of all, accept those recommendations, and were they able to implement some of those solutions, and what were the impact of those?
We've already actually presented these to our client, but that was just really recently lang, as in last week lang po. So as to whether they'll implement, it remains to be seen. So.
Okay, thank you.
So thank you for that presentation. So continuing our oral presentation, let me call on Dennis Christian Aleta as he presents his group's research analysis of fabric attachment failure. Okay.
Bro, I've been wondering that my entire presentation. Okay, this is next slide.
Which one?
Ito po ba? Previous slide, next slide. Pause. Ito yung Hindi, back that. Previous, next. Facing. Tapos first slide.
Hello. Okay. Sige, before I start po, so ito po yung actual na failed sample namin na in-analyze. And it's actually from our client, which is nandito rin po sa auditorium right now. Okay? So, okay, start na po. Okay, so good day. We are here to present our case study titled Analysis of Fabric Attachment, Failure Between Patajong and Honeycomb Fabrics in the Official DOST PTRR Uniform. So today we will cover the problem statement, background, methodology, results, and our post-assessment evaluation. So our client reported a recurring mechanical failure in one of their official uniforms. Specifically, the seam between the front yoke and the sleeve has opened, leading to visible separation. So the client hypothesized that this could stem from the thread breakage, fabric pulling, uneven stress distribution, or cyclic loading during wear. So here is a more detailed look of the said failure. We can see in the specific part of the garment, ayan, that failed and where it is located. And according to the client, their institute already experienced 5 out of 100 plus units of polo shirts that experienced the same failure. So to investigate failure, we constructed this Ishikawa diagram to map out potential contributors across man, machine, method, materials, measurement, and environment. While factors like loose stitching or improper use are probable, this study focuses on materials due to project constraints. Consequently, our objectives center on evaluating the material properties to pinpoint possible causes of this failure. But before we head to the study proper, it is important to understand the fabrics used. So first one is our patajong, the hand woven patajong, the blue one on this shirt, and the knitted honeycomb fabric, the white one. So which are joined in the garment. Patajong follows a plain wave structure characterized by the crisscross pattern of yarns. Garment construction follows standardized stitch and seam classifications based on the ASTM D6193. So this study covers the garment manufacturing process from pattern making to finishing. The two fabrics differ in yarn geometry. Woven fabrics consist of interlacing yarns, while knitted fabrics consist of interlooping yarns. These structural differences are expected to influence their mechanical properties. Now, for woven fabrics, the yarn directions are warp, yan, lengthwise thread, and then weft crosswise, or the running one, running. So for weft knitted fabrics naman, ayan, the corresponding directions are the wale and course. And why is it important to understand? Because according to textile mechanics, fabric structure may actually significantly affect overall mechanical behavior. So the client specifically requested that no further destructive testing to be performed on the original polo shirt. Therefore, sample replication was conducted. Yan. Replicated samples used stitch type 301, also known as the running stitch, with a stitch density of 10 stitches per inch, or SPI. While overlocking was applied for the edge finishing. Ito sila. The replicated samples were designed to closely match the original polo shirt, while complying with relevant standards. The weft direction was followed for woven fabrics, and the course direction for knitted fabrics. For the methodology, a visual inspection was first conducted as a non-destructive test to assess the severity of the failure. Preliminary testing was then performed on the raw fabrics for characterization and supporting data purposes. Finally, several destructive tests were conducted on replicated samples to simulate the possible causes of failure. Now, for the visual inspection, it allowed us to measure the seam opening length and the diameter of the front yoke attachment. Now, for microscopy, it provided us the necessary data for sample replication and testing. So, yung garment was found to have that 10 SPI with a separate overlocking stitch. Ito siya. Actually, if you can zoom in and siya yung puti-puti. And then the fabric orientations were identified as weft, and for the patajong fabric, and course for the knitted honeycomb fabric. Now, as a characterization, FTIR analysis was performed to determine the composition of the two fabrics. The first spectrum corresponds to the honeycomb fabric, while the second represents the blue region of the patajong fabric. The third and fourth spectra were obtained from two different segments of the silver intersection area of the patajong fabric. All spectra exhibited similar peak patterns, suggesting a common material composition. Yan. So, at strong absorption peak was observed in the range of 1710 to 717. So, indicating ito na meron daw siyang ester stretching, which is actually the diagnostic peak for polyester. And then additional peaks naman sa 1240 to 1270 and 1090 to 1100, indicating aromatic ester and CO stretching vibrations, respectively further confirming the presence of polyester. And then may notable peaks tayo at 720, yan, sila na may aromatic CH bending peak, and small absorption bands around here, 2900, which may be associated with fabric treatments such as dyeing or the incorporation of biocolorants. And then overall, the FTIR results confirm that both fabrics are composed primarily of polyester. Therefore, it can be inferred that the observed failure is unlikely to have originated from differences in fabric composition. So now, as an additional characterization, tensile testing was conducted following ASTM D5035, also known as the strip test method, with specimens conditioned according to ASTM D1776. So 5 samples from each fabric direction were tested under 1 kilonewton load. So from here, we can play this one. So yung results, ito sila, nahati yung ating mga patadyong. Ayan, nagkaroon ng unraveling. And then ito naman sa ating knitted, ayan, na-stretch siya to its limit. And then ito naman, whale direction, nagkaroon siya ng failure, rupture. So yung results sa atin indicating lang na yung warp direction for patadyong is actually stronger for weft direction. However, it indicates din na it is more rigid, and choice of direction may affect the general garment attachment properties. And then yung data from this one will actually be useful to confirm yung magiging data for the destructive tests. So for laundering naman, this is a destructive test performed on the replicated samples, simulating 1 to 2 months of hand washing. So yung result natin indicated a 19.89% dimensional loss, and meaning na yung washing natin can actually shrink, quote-unquote shrink yung ating mga woven fabrics. Well, to be fair, it's just the unraveling part for this one. Ayan. Tapos, ito yung itsura nila after, before and after. So, nagkaroon ng malalang unraveling after na malabhan yung ating mga fabrics. And for our confirmatory test, seam breakage naman, what we found here was that yung mga non-laundered samples, they actually had a larger or stronger resistance against tensile pulling. So, in this context, yung complete failure kasi natin indicating separation of seam. Yung patadyong natin, unraveled, ayan, yung patadyong during the pulling, unraveled, unlike yung ating knitted honeycomb, remain intact. Ayan. Next natin na destructive test was actually the seam slippage. Medyo similar siya sa ating seam breakage. However, unlike the seam breakage, this one, complete failure siya. So, pulling until mag-split yung ating fabrics. For seam slippage, we intended to mimic yung naging actual failure dito sa polo shirt. So what we found out here is that, ayan, after ng pulling, naiwan yung mga threads of patadyong doon sa ating knitted honeycomb and doon sa seams niya. Ayan. And actually, na-weaken din, after laundering, na-weaken din yung kanyang mechanical structure. Kaya most likely, may factor talaga yung paglalaba and yung difference ng dalawang fabrics. So now, going back sa ating Ishikawa diagram, so ito yung conclusions namin per factor. So yun nga, laundering caused dimensional loss, creating tension that can pull the seam over time. Tapos yung ating namang fabric geometry, may differences yung dalawang fabrics. And then yung incompatibility between fabrics, most likely dahil nga sa difference ng dalawang fabrics, nagkaroon ito ng factor doon sa failure. Ayan, so ito yung na-mention ko kanina about sa differences sila sa fabric properties. And then this one, yung actual failure, to which yung sinasabi ko kanina na naiwan yung patadyong yarns doon sa may seam. Yan, doon sa may seam and sa may knitted honeycomb. So dito, intact pa rin siya, pero dito, nag-split na. Ayan, so yung recommendations namin would be that try testing different stitch parameters such as yung seam type natin to utilize yung seam type para hindi ma-expose yung edges natin during testings. Tapos ito, fabric compatibility, since na-mention nga natin na may differences ang knitted honeycomb doon sa may hand-woven fabric, patadyong, might as well consider if compatible ba talaga yung dalawang types of fabric when sewn together. And then isa pa, care instructions, kasi if I'm not mistaken, walang care instructions para sa hand-woven fabrics, garments. Yan. So, and based dun sa aming study, actual laundering may actually affect yung overall properties. And then more testing methods such as yung chemical analysis, so burn test, to support further yung ating FTIR. And yarn slippage naman, fatigue testing, and then simulation. Although, if I'm not mistaken, then yung simulation is actually can be physical or through FEA. However, for FEA, medyo mahirap pa siya for fabrics kasi there might be several computations or extreme measurements na kailangan para magawa yun. Pag physical naman, you might actually want na to test it with through real people na sila yung magsusot ng damit. Thank you. Ang dami ko po na-skip.
Thank you. So, your group mates may join you on stage for the Q&A. So, are there any questions from the audience about the presentation? Or panel, from the panel?
Hello, Dance and group mates. So, medyo similar yung question ko ngayon sa question ni engineer kanina sa earlier group, no. Since nandito yung inyong client, ang curious ako kung ano yung response nila dun sa recommendations na pinresent ninyo or kung na-present nyo na ba to sa kanila.
Actually po, sila rin po yung nag-recommend sa amin ng recommendations. Pero po kasi, we believe din na kulang is yung naging testings namin, in a sense na hindi pa niya actually na test yung bulk properties nung as a shirt. Kasi ang na-test lang namin is yung specific part niya. Then how about kasi if yung actual different fabrics, nagamit siya sa bulk ng shirt. Kaya may recommendation sa ganun para ma-test niya as a whole.
May question ako sa set ninyo of tests na ginawa. Siguro, coming from the fracture that you actually, parang it's a mechanical failure, right? Yung nakita natin na failure was actually a mechanical failure. So siguro, I just want to understand better. Can you give us some clarification on the thought process that you went through in the subsequent tests that you did to actually understand the mechanical failure?
Sorry po kasi nagmadali na po kanina. Pero ang thought process po kasi dyan is, initially, i-characterize muna namin yung raw fabrics para malaman namin kung possible bang factor yung difference sila sa properties, initial properties sila. And then yung next sa testings namin is actually simulation na siya ng real life natin, to which yung una was laundering. Diba? Ideally kasi nilalaban natin, dapat makasinasuot natin. And then the other one is yung sa tensile naman. Kasi diba, yung yoke, itong specific section ng damit is actually, di ba, nagagalaw siya. And might be because of extreme range of motion movements, kaya yung testing namin was tensile. Kasi kapag ginalaw mo siya, essentially, parang ka nagkakaroon ng tensile movement dito sa part na to.
Follow-up lang. So in terms of, I agree no, na medyo tensile nga yung, siguro, I mean, in general naman, weakest naman yung materials natin under tension. So therefore, kung meron tayo loading na i-test sila, pinaka-conservative test, kumbaga, is yung pag-apply ng tension. Ngayon, ang tanong ko is, from the process that you went through, it seems that you were simulating, right? So therefore, nung nag-apply kayo ng tension, did you consider the amount of load that was actually going to be applied by doing this movement, kunyari? That's now going to be the consideration in terms of what amount of load will be applied to yung material na parang sinunyo para maging simulation siya dun sa actual fabric.
So we initially considered po, meaning following the standard, to have a better understanding po on how each fabric would interact, or rather the fabrics would interact to the applied load. And that's why we further suggest po sa recommendations to have a more accurate testing on how the tension is applied to, especially po sa fabrics, kasi unlike po sa UTM alone, it's just one direction, but realistically po kasi it could be stretched in multiple areas or in range of motion. So the stretching could be further better simulated, as discussed nga po ni Dance kanina, na real life simulation. So yung everyday activities will be applied, and how the apparel or the garment rather would react to these various actions around the area of failure.
So essentially po yung naging study is like, nagbigay na po siya ng insight na may chances na mangyari itong ganitong klaseng failure if naging ganito yung construction ng ating garment. Unique siya.
Okay, so first of all, very good job in coming up with very scientific materials analysis with a simple, rather everyday object. So kudos to you guys. Thank you very much. So balik ka na sa Ishikawa diagram mo. And if I remember the number, can you go back to that slide? You're saying there's about 5 out of 100 fallouts? Is that the number? 5 fail out of 100, tama? Yung number ko?
Yes.
Lumampas.
As reported po sa slide.
Yeah, okay. But 5 out of 100 is the failure, which means there has to be something abnormal out of that 5. What about the 95? What are they doing right? Have you thought about that under your Ishikawa?
For the other 95, we actually, the 5 out of 100 plus was, I think, we took this insight from consulting with with the client. So we have no access po talaga on what happened to the other 95. Maybe there might be signs of failure in the other 95, like that is not as observable as this unit, but perhaps the 5 units that had the same or similar failure would give us has given them a thought or insight that maybe there's something about the fabrics enough for us to test or to study more into the field.
Siguro to add na lang po, I wish we to recommend din for future research is to also inspect again these 95 successful units, and then to compare this with the actual failed para lang makita po namin ano yung naging differences at sa nagawa ng handloom, if ever, and also the stitching types as well, and basing on their fabric geometry. Yes.
Right. So, just a word of caution and at the same time advice that in the real world, your management will always ask you the same question. If it's just a 5 out of 100 and 95 is doing it right, and its cost-benefit analysis turns out to be profitable in the long run, maybe it's cheaper to scrap rather than to rework, right? So, real world lang. Thank you very much.
Thank you for that presentation. And now we proceed to the next group. Let us welcome Marielle Rose El Loreto as she discusses her team study. For the group mates, kindly stand by on this side so that you can easily go in front during the Q&A. Thank you. Also, let's be wary of the presentation time to avoid delays. Thank you.
Okay, so good afternoon, everyone. I am Mariel Rose, and this is the study of our group together with Katabay, Sarkon, and Henoa, the failure analysis of MTRAC High Plus 42B 20L battery. So for the background, this numbers here shows the main causes of failure in car. So 43.2% are because of the battery. So that's why our group has decided to study about the failure analysis of the battery. So MTRAC Plus, it's a sealed maintenance free with silver alloy technology. The model is 42B20L, and the cold cranking amperes is 335 amperes based on the specification sheets. And these are the other details. So here is the specification sheet. And for our problem statement, the MTRAC High Plus battery failed after 12 months, approximately 20 to 25% of its rated service life, and the root cause and failure mode are unknown. The client, which is the Motolite at the CP Garcia branch, distributor and manufacturer, the Philippine Batteries Incorporation, are distinct parties. Attribution requirement determine whether the failure originated in use conditions, material quality, or the manufacturing process. So for our objective, it is to characterize the electrochemical and physical state of the failed battery, to identify the characteristic of the failure mechanism through internal examination, to quantify the plate degradation using image-based analysis, and to map the probable causes via Ishikawa causal diagram, and to recommend confirmatory tests for root cause determination. So for our initial investigation, tinitingnan lang po namin yung external, which is meron pong visible dust and dirt accumulation. And sa external, walang cracks or bulging, warping na nakita. So outside, mukhang intact yung battery natin. And also, the terminals look slightly worn due to deep scratches visible. So ito lang po yung zoom out picture. So for the open circuit voltage and load testing, the OCV or analog tester shows 13 volts measurement and drop to 10.2 volts under applied load. And sa digital BT60 tester naman po natin, 12.70 volts, which is yung reading natin falls in the nominal range. So the cold cranking ups naman na measurement, it shows na 144 cold cranking ups, which is kung kukumpara natin sa specification sheet, dapat po ay 335 CCA siya. And ang state of health na pinakita po sa testing natin ay 33%. So significantly capacity degradation confirmed. And the predate electrolyte and cell behavior naman, upon opening yung vent caps, nakita natin na 4 out of 6 cells are electrolyte fully desiccated or dry, which is not a good condition kasi as a battery po, in-expect na mayroong electrolyte, so dapat mayroong visible liquid sa loob po ng ating mga vent caps. So non-uniform cell condition consistent with expected na advanced suffocation or internal damage, but we will discuss it further sa next slide. So performance summary lang versus the rated specifications. The red one is our performance summary, and yung expected po based sa specification sheet natin ay yung color blue. So makita po yung difference there. So comparison lang natin, no? Kung kanina ang OCV natin is 12.7 and nakita na nag-drop siya to 10.12. Actually yung OCV natin, expected kasi sa battery na meron siyang 12 volts. So kung OCV lang yung pagbabasihan natin, parang wala kang makitang problema. Pero upon applied load, in-expect na yung voltage natin is magdadrop, pero up to 11 voltage lang. Pero based sa na-measure natin, it's 12.2. Plus, idagdag pa natin yung na-measure na CCA, which is in comparison na 144 shots versus 335 based sa specification sheet, and then yung state of health natin, which is 33%. Okay, for the evidence management, the chain of custody, so the customer complaint received by Motolite, the branch here sa CP Garcia, and then the Motolite staff drained the acid and wiped the casing before transport. Then specimen transported here sa DMMM, then sectioning and evidence handling are done by the group themselves. So gusto ko lang din po i-add upon the limitation po na nakalagay dito, na drain po yung acid by the Motolite staff. So limitation siya ng study in a sense na hindi po namin na test muna yung laman ng battery before siya ma-drain. So next is yung sample preparation and storage. And then for the control disassembly na po, the sectioning was done to access the leftmost cell, which is yung filled cell po natin, and then the adjacent naman, which is yung functional. Yung functional natin, nasabi natin siyang functional kasi meron pang electrolyte sa loob niya as compared dun sa leftmost natin na kabilang siya dun sa dry. So only 2 cells will be analyzed, which is, we labeled it as failed versus the functional or working cell. Next is, ito lang po yung zoom out ng cross-sectioning. Yung may mga lines po, yun po yung kinos-section natin. And then yung nakalagay po, naka-highlight na green, yun po yung nilabel natin as working cells. So for the field cell analysis, first is the sulfication po. Nakita natin na mayroong light gray deposits and the deposits concentrated on the convex outward bulge ng plate. And the visual appearance consisted with the lead sulfate. Next is naman yung plate deformation and buckling, which is the plates curved and twisted, and then the warping collocated with deposits concentration on the convex region. Deformation heterogeneous across the plates within the same cells. So sa yung mga cells po natin, di ba nabanggit po kanina, merong 6 na cells, and then sa cells po na yun, merong 5 na grids. Sa 5 na grids po, magkakaiba sila ng bulking, kaya po nasabi namin na deformation is heterogeneous. Next, yung grid degradation and active material shredding. So nakita na may nagde-degrade po yung ating grid, and may mga active material na nag-shred, which is nakita na nag-deposit po siya below the battery. So next is yung sludge accommodation. The gray block sludge confirmed at the base of the failed cell consisted with the shed active material. So volume substantially exceeds that of the working cell. Next is yung separator cracking naman po natin. May kung makita, here po sa left is yung working cell, and here naman po sa right is yung separator ng failed cell. So makita po natin yung mga visible cracks niya. Next is yung physical evidence confirms, a summary ko lang po, which is yung plate warping, active material shedding, sludge accumulation, and separator cracking in the failed cell, all consistent with significant electrochemical and structural degradation, plus yung grade deposits natin, which is consistent naman with sulfication. But it awaits a chemical confirmation for that. The next naman po, comparison lang po kung ano nakita natin sa working cells. So, ito lang po yung comparison. Makita po sa left yung ating failed cell, and then sa right naman po yung working cell. So, makita niyo po talaga yung degradation or ng grids natin as compared sa failed cell saka sa working cell. And then, ito na po yung buckling between the failed cell saka sa working cell. Plus, yung makita niyo rin po yung separator cracking. Ito po yung sa failed cell, then the working cell. And then, next naman is yung sludge build-up between the two. Next, for our quantitative results using image J, so sa buckling angle quantification, ang method po natin is tangent line angle tool deviation from 180 degrees recorded. So based sa working cell natin, mayroong 10.15 degrees na deviation from flat, while sa failed cell naman po natin is 24.94 deviation. Ang limitation lang po nitong measurement na to is perspective error from the handheld topography, and 2D lang po kasi siya. Then next is, ito lang po yung sa graph kung ano yung difference ng dalawa regarding sa buckling angle quantification. Next is the active material loss quantification or the percent area removed. So ito po yung sa working cells natin sa left, and then sa failed cell naman sa right. So ginamit po natin is yung image J po. So sa working cell is 5.01% area removed, while sa failed cell naman po is 8.63% area removed. So sa failed cell shows 1.7 times more loss in average. And meron din po nakita tayong high standard deviation in failed group, so degradation is not uniform across the plates. So limitation naman po nito is single baseline plate, shadows may underestimate the removal. Next is the causal analysis naman po for our Ishikawa causal diagram. Meron po tayong nag-branches po siya into 6, which is human user methods, machine and manufacturing process, materials, and environment. So for our recommended confirmatory test rin naman po for the grade deposit is SEM-EDX for the required confirmed sulfate identity. Then grid degradation is the cross-sectional metallographic analysis, while the separator is chemical or microstructure characterization, and temporal failure sequence not yet established from the physical evidence. So next po, summary lang po natin ng findings. Yes, nakuha po natin electrochemical and physical state of the battery. Next is identify the failure mechanism through internal examination. So for our major failure mechanisms po, this is the group assumes na sa overheating po due to the corrosion, short circuits, and overcharging, which dries up the electrolyte, and overcharging po, deep charging cycles may cause active material to shred, and repeated expansion po ng plates natin and contraction. Next is low electrolyte level, causes lead plates to dry out and exposed to air. The next is manufacturing defects, which leach space spreading may contribute to the shredding of the material. Next is yung quantification lang po natin using image J basis, and yung pagpumap po natin ng probable cause, which is upon here sa analysis po natin based on the chemical analysis of the battery, significant degradation was observed as measured po sa electrical performance. In addition po, mayroong difference between sa degradation ng working and failed cells. So therefore, the failures most likely attributed to operational and usage-related factors rather than inherent manufacturing defects. And ito po yung recommended again na confirmatory test po natin for the root cause determination. So that's it for our presentation.
So thank you. Your group mates may accompany you on stage for the Q&A.
Hello, good afternoon. Tama ba, Doc? This is lead-acid battery, tap ba?
Yes po.
Lead battery, no? So, I'm asking this question kasi I used to work in Motolite, no? And yung primary method namin when analyzing yung mga failed batteries is metallography, no? You look at the grids, tingnan yung kung ano yung internal structures nila, and make conclusions from there. So I'm just curious, wala kasi ako nakitang metallography, no? Is there a particular reason bakit hindi nyo siya in-include?
Upon consultation, nagko-consult din naman po kami from Motolite. Nagtatrabaho rin po sa Motolite. Actually, when it comes po sa metallography analysis, wala pong nabanggit sa amin. And kung tutusin po yung span lang din po nung to do the failure analysis is 1 SEM. Ang na-achieve lang po ng group namin is to quantify the image po. So, nilagay na lang din po namin sa recommended, na which is we acknowledge po na need nga po na metallography analysis po for that.
Well, I have a similar question to the previous group, but I think you were able to two things, tie together the causes and then the data, and you were able to come up with suitable recommendation as well, no? If I look at go back to your Ishikawa diagram. Oops.
Yes, sir.
All right, so it seems like you pinpointed mainly material issues as sort of the culprit of the failures, right? Were you able to sort of dive deep into the procedural then? For instance, baka naman overuse lang yung battery kaya talaga nag-degrade siya over time.
Actually po, sa conclusion po kasi namin, ang mismong conclusion po namin is the failure is mostly attributed po sa operational and usage-related factors po, not on the, so mas, ang
So it's
conclusion po
customer
talaga
use.
sa customer use po,
Right,
yes
okay.
po.
So are you saying therefore that kung ako vendor ng battery na to, can I assume that it's a user issue rather than a manufacturing defect?
For that po, I would say hindi po siya ganon ka 100% sure. Kaya po may mga recommended pa po na confirmatory testing. Kasi kung titingnan po talaga yung battery, it's very complicated kasi marami po siyang materials na kino-consider. So, I would say I'm not 100% not confident po about
Okay.
the sinasabi po namin na more. Pero dun po sa nasabi, mostly yung mga na-discuss po namin na failure, yun po yung ma-attribute namin sa usage use po.
Okay, thank you very much.
Yes. Okay, pwede pa. Okay. Hindi lang naging clear sa akin masyado, no? Pero I wanted to understand, or siguro pa ulit lang siguro ng pagkasabi, baka hindi ko nakita. Pero yung hindi malinaw sa akin kung ano yung naging initiation nitong, ano yung failure report, kumbaga, ano yung failure incident probably. Kasi kung nakita ko lang dun sa diagram is may customer na nagbalik ng battery sa Motolite, which is actually a regular practice, di ba? Kapag nag-wear na yung battery, parang pwede mo siyang ibalik sa Motolite. To know kung was this a pure failure that, of course, is a typical reason for failure investigation, or this was the typical practice na nagkaroon na talaga ng wear yung battery kaya binalik na siya sa Motolite.
Okay. Nakalagay po kasi hindi na po talaga siya totally working po upon 12 months po, which is ang expected po, which is not the expected service life po ng battery. So, yun po. But
Expected service life siya?
hindi po. Yun, ang expected service life po is actually, as I believe po, is 2 to 3 years po. Unlike po kaya po, pero yung battery po, binalik na po siya upon 12 months.
Okay. Okay, sige. So, siguro yung ano lang, magandang ma-recommend nga yung from the perspective of the end user nung battery kasi yun yung potential. Right now, you're not seeing directly coming from failure nung, diba, nung battery itself. Tapos, baka nandun nga sa end user. Kailangan maintindihan din from their side.
Thank you po, Doc.
So thank you, Mariel, for presenting your group's out. And now to conclude our oral presentation. So, sige, pakan natin si Mariel. Okay, so we are down to our last group. So let me call on Juliana Josefa B. Rezano, the podium, to present their group's research.
Okay, so good day everyone. I am presenting our failure analysis of steam boiler pipes in a coal-fired thermal power plant. So let us begin with a short introduction to where this failure occurred. So it occurred at Company X, and Company X operates a 600 megawatt coal-fired thermal power plant, and they have 4 units of boiler systems which generate steam and power. So our incident involves 3 tube samples in Unit 1 of the power plant. Moving on, the failure was initially detected last May 24, 2025, when an operator heard a loud hissing noise coming from the hot reheat area. This was accompanied by a sudden increase in makeup water boiler consumption, so this led them to report this, and a shutdown was initiated 2 hours after it was initially detected. Moving on to our sample overview or materials overview, we have 3 failed samples, and we named them sample 1, 2, and 3 for our investigation. And all these tubes are in one area, or the hot reheat area, and it is near a rotary soot blower. These tubes do not contain the same steam, but rather they are just located in one place. So sample 1, or reheater tube 1, it is used to reheat steam exiting the high pressure turbine, and sample 2 and 3 are adjacent tubes, and they are both HRA right side wall tubes, and they are used to distribute superheat steam to the HRA lower header before going through a series of superheater panels. So its working condition is presented here. And then, so all these tubes are expected to have a useful life of 57 years. However, sample 1 or tube 1 failed after 14 years, and sample 2 and 3 or tube 22 and 23 failed after 3 years. Thus, we are conducting failure investigation because these tubes experienced premature failure. Moreover, the emergency shutdown caused by the failure of these tubes led to financial losses and safety hazards for the company. So we have 4 main objectives for our failure investigation, which is to propose the likely sequence of failure, to determine the likely causes and failure mechanisms, to evaluate some factors on the to evaluate the influence of some factors on the observed damage, and to develop evidence-based recommendations. The company was able to provide us photographs of the as-found condition of the samples, and as we can observe, the nearby samples remain undamaged, which suggests that the failure was localized rather than a systematic failure. Moreover, we can also infer that the failure started in a single tube and progressed and affected the adjacent tubes. Upon closer inspection, we can see that sample 3 has two smaller holes, which is the pinhole rupture and the smaller elongated rupture above, and then it had one big hole, and sample 2 had one rupture, and sample 1 had one rupture as well. So the client was also able to provide an initial report on the sequence of events for the failure, and from the report, the failure started from sample 3, from the pinhole rupture, and the pinhole rupture caused steam to impinge on sample 2, which then caused steam impingement again onto sample 3, causing the bigger rupture to occur. And then the steam impingement from sample 3 impinged on sample 1, which caused its failure. Upon closer look, the membrane wall between tube 22 and tube 23 exhibited multiple perforations, and these perforations gradually became smaller as it approached sample 3. So this is evidence of a directional progression of damage from tube 22 towards tube 23. Moving on, we can also notice some discoloration on both sample 2 and sample 3. However, for sample 3, the discoloration is mainly yellow, and for sample 2, the discoloration includes yellow, dark yellow, and brown, and these are indicative of heat tints or burn marks, which may be caused by longer exposure to high temperature steam, which is, again, further indication that the large rupture in tube 23 is caused by tube 22. Moving on, we conducted investigation on tube 23 on its weld and body, and from visual inspection, we can see that there is poor weld quality for tube 23, and in the area of the initial rupture, there is an undercut or groove along the weld bead, and this may be caused by improper welding parameters. Moreover, tube 23 also experienced significant wall thinning, wherein its wall was reduced into half. Lastly, we conducted dye penetrant tests to determine if there are any defects noticeable, and the red spots that we see, or the red dots that we see, are evidence of porosity. So porosity is a common weld discontinuity caused by the entrapment of gases during weld metal solidification. So from these evidences, we can suggest that the initial failure of tube 23 started from weld defects. We also conducted inspection on the bigger rupture in tube 23, and we can see that the bigger rupture has a deep bulge around it, and that the cross-section of this tube remains nearly circular, suggesting that the failure came from external forces. We conducted micrographical analysis on the cross-section of the tubes, and we can see that in the undamaged surface, there are no evidences of spheroidization or such. However, for the ruptured zone or thinned area, there is some degradation of the perlite structure and also some formation of spheroidization, which is evidence of overheating. So overheating could change the microstructure of the tubes, and so possibly the other failure mechanism of tube 23 is overheating from steam impingement coming from tube 22. Moving on, we also conducted investigation on tube 22, and as you can see from visual inspection, it had a fish mouth rupture, and there was severe localized wall thinning around the ruptured area. So these are consistent with mechanisms of short-term overheating, and there is no strong evidence of internal corrosion or erosion, which is consistent with the as-found conditions of the sample, wherein they did not observe any corrosion products present. We then conducted sectioning, and those labeled with 1s are parts where the failure occurred, and those labeled with 2 are the parts where there is no failure occurrence. We were able to conduct dimensional analysis after sectioning, and we can see that the thinning was highly localized near the rupture area, which is consistent with short-term overheating failure mechanism. So the average tube thickness is 5.11 millimeters. However, for 2A1, 2B1, and 2C1, we can see that it was reduced to 4, 3.5, and 2.9 millimeters. We conducted micrographical analysis to further confirm our suspicions, and as we can see, the failed or thinned surface had degraded bands of lamellar perlite and some growth of spheroids, and the major difference in microstructure indicates that the failure was localized. So this is the micrographical analysis for the area with the rupture. And then the area with localized thinning, baliktad yung photo. So this on the left is the failed or thin surface, and on the right is the undamaged surface. So as you can see, the circled areas are some spheroidization, and the perlite bands became more disorganized or degraded. So these are signs of thermal degradation possibly caused by the steam impingement from tube 23. So from that, we conclude that the steam impingement from tube 23 caused the thinning of tube 22, leading to short-term overheating. Moving on to reheater tube 1, from visual inspection alone, we can already see that the failure started from external forces talaga, since the erosion shield, which is supposed to protect the reheater tube 1, it experienced significant damage, even more significant than that of reheater tube 1. It has significant thinning and the rupture is observed. So we can also notice that there is inward deformation at the rupture opening, further supporting the external origins of the failure. We conducted replica testing adjacent to the rupture, and we can see that the sample maintained or retained its original microstructure, which means that there is no overheating mechanisms involved. However, there are some evidences of spheroidization, which could possibly be because of the steam impingement. So we created this causal factor diagram, and the ones in gray color are the likely causes of the failure. So we propose that the pre-existing defect or damage, possibly the weld defects at the membrane to tube weld, contributed to the localized stress concentration and then caused tube 23 to initially fail, then affecting tube 22 and tube 22 and tube 1. So we have these recommendations for preventive actions for future reference, which is to strengthen tube inspection and monitoring during shutdown maintenance, to improve leak detection systems, to conduct periodic inspections of welded area and tube surfaces during maintenance, and to implement stricter monitoring and alarm thresholds for makeup water consumption, and investigate abnormal increases immediately. So for our conclusion, the weld defect is what initiated the failure, which is the weld defect we observed in tube 23, and tube 23 then affected tube 22, and so on. So that is all. Thank you.
Hello. Thank you, Juliana, for that presentation. So your group mates may accompany you on stage for the Q&A. So any questions from the panel, the audience? Sige, ako na lang siguro magtatanong. Okay, so were you able to test the mechanical properties of the tube samples as well? Kasi may na-mention kayo na may possible spheroidization. Pero have you, aside from the microstructure analysis that you did, were you able to compare kung may na-observe ba kayo na, or yun, kung may data kayo of, for example, let's say hardness, to confirm your microstructure analysis?
Unfortunately po, we were not able to conduct any mechanical testing on the sample. So the only evidence we really have is the microstructural analysis.
Okay, okay.
Hello, Jules. I would just like to congratulate your team. No? Sobrang detailed and maganda yung failure analysis na ginawa niyo. No? Yung question ko lang, just more of a clarification lang to, no? Kasi I'm looking at the diagram. Yung parang indicator nyo kung saan yung failure is somewhere in the middle of the tube, no? So, pero yung root cause na na-identify nyo was the weld defect. So, hindi ko lang ma-imagine kasi I would imagine yung seam ng weld is further up. So, tama ba? Or may weld din dyan sa area na yan?
So yung tube 22 and tube 23 po, naka-weld po sila to a membrane wall. So itong area po na to is connected to a wall and there is weld here.
Okay. So, merong weld dyan na hindi lang pinakita sa diagram?
Hindi lang, po.
Okay. So, medyo nalito lang sa drawing. So, kumbaga, itong specific area na yan, wineld talaga
May weld
siya?
po, yes po.
Okay. Would you know kung anong klaseng weld ginamit? Butt weld ba? Or
We were not
lang?
able to ask our clients po on how the welding
I mean,
was done.
the shape lang. Ano ba yung itsura niya? Naka-angle ba siya? Or parang butt to butt ba? Or parang lock?
From pictures po kasi, or when we received our samples, medyo,
Okay. So, meron kayong images on yung weld na, ano tawag dito? Yung weld section, yung pinapakita yung, kumbaga, yung shape ng weld natin across the area. Wala. Alright, sige, okay lang. Pero that would also give you an idea no, kung gaano kaganda yung weld. If it's, you can look at the contact angle, no? Kung maganda yung contact angle, it indicates good spreading of the weld material, which could indicate a good weld. Tapos kung hindi maganda yung surface, yung contact angle niya, probably isa din yung sa reason no, bakit mayroong ano. So maganda sana kung napakita niyo yung at least yung cross section ng weld.
May cross section po pala kami ng tube. This one po. So
Yun, meron.
yan po yung area mismo nung may weld defect. Yung naka-circle po. And then yung right, mukhang yun naman po yung medyo okay na weld.
Okay, so based sa shape na mukhang okay naman dapat pero nag-thinning, nagkaroon ng thinning. Okay. Yun lang, thank you.
Can you go back to the slide about your recommendation, including the point where you mentioned about increased welding inspection or something to that effect? Ayun, yeah, okay. So when you say conduct periodic inspection, that's your recommendation, right?
Yes.
Do you have any idea kung ano yung current frequency of inspection versus what's going to change because of this failure? Monthly, quarterly?
So from what we know po, the operations of the power plant kasi is continuous. So they are only able to conduct maintenance or inspections after some years lang, like perhaps yearly or every after 3 years. So that is why possibly po the failure remained undetected for quite some time.
Yeah, so for sure there's going to be something that will change as a result of this failure, right? They would probably enhance that. Second link to that question is, when you go back to the weld area in particular, were you able to find any mechanical anomaly other than the material anomaly you've seen here in welding? For instance, baka naman merong something that's touching that or interfering with that, or in other words, one level down. Hindi lang, kasi when you mention weld defect, questionable na lahat ng welding mo sa buong piping, right? So you have to be very, very careful in pinpointing. Pag sinabi mong weld defect, in question ka na sa lahat. So you have to go one level down in terms of ano pa ba talaga yung besides the weld defect. Abnormal ba talaga na procedure yon, or is it something that's causing that in effect? So yun yung maybe as a recommendation moving forward. Especially in an operation like this where time of the essence. Tapos yung frequency of inspection, it takes a year before you can really, perform the whole pipeline. Thank you.
So, sorry.
Last comment na, hindi to question, more of suggestion lang. I think sobrang ganda ng data nyo and yung pagka-story nyo sa paper nyo, no? And there is a possibility na pwede nyong i-publish to in some conference or some publication related to FA. So if you would like, parang maganda nga na i-pursue nyo siya, no? So wala lang, kasi sayang yung data, no? Maganda yung na-collect nyo, maganda yung naging interpretation, no? And yung root cause analysis nyo. So I would suggest na pursuing a publication, no? Kung sakali. Maganda yung pag-graduate nyo, at least meron kayong publications.
Yes.
Thank you very much, ladies and gentlemen. Is this one of the SEM Calaca plants? Is this one of them? Okay. So my question is posed to Stan, Nat, and Jason. From what you have seen, that they have seen, and what you have done, is there a consistent, what you call this, consistent analysis or consistent finding that you can connect with what you saw and what they saw?
Sige, ako ang sasagot.
This is what I'm saying now, that this is a situation where a student project and a professional project should be consistent. Or if they are not consistent, at least tell us at what point are they not consistent, so that we can again ultimately enhance the service offering of the FA Hub. So, ikaw ba sasagot that?
Yes, sir.
Okay.
Actually, sir, for context po, ito pong samples na ito ay
Apply to
provide...
the SCPC 1 or 3?
SCPC, sir.
3.
SCPC 1.
Don't be shy. Chris Gutiano says we must publish what you have done.
Okay. So, I believe
You
SCPC...
can disclose. Sige, sige.
Sige, okay lang, sir, na magsabi ng name.
This is supposed to you eh.
Sige po. So, as far as I know po, ang samples na po ito ay from either SCPC Unit 1 or Unit 2. So, ito po yung isa sa mga, yung pinakamatagal na po nila na operating na plant. And yun po, for context po, samples po na ito ay yung initial po na pinadala nila last year pa for establishment nga, or for methodology development nga po ng failure analysis hub for the boiler tubes. And yun nga po, from their presentation and the results that they have present, I can personally say as a failure analysis engineer na their methodologies and the analysis that they have done is consistent with what we have done and what we are currently doing here at the FA Hub, especially in analyzing well defects. Ayun po, siguro there are points lang po na they can, yun nga po yung tinanong ko earlier, so they can acquire more data to describe the mechanical property for more detailed characterization of the failure po. And as well po, they can section more parts so that they can have more detailed analysis po of how really the failure started in these samples po.
Thank you very much, Nat. So, again, students of failure analysis, you are very lucky. You are very lucky because your professors have seen the place and they're able to correlate, tie up with what students have found. You are very lucky. Because in other cases, the professors never know what they're talking about. Okay? No, let's be honest. But in your case, these guys have seen it, Stan, Nat, and Jason, and they are saying what you have done is consistent with what they have seen. So congratulations. And this is the success of the Failure Analysis Hub, the combination of industry and academia. Thank you.
Thank you, Sir Tito. And ayan, that concludes our oral presentation for today. So before we proceed to the next part of this program, we'll have another coffee break, a short coffee break. So there's a food is served at the floor room, the second floor. So kindly show your food stubs to the personnel there. So thank you. Okay. So please be back by 4 p.m. Patay na nga yung isa.